And we're back. So
Yes, we are.
Coffee. And here's Dave. Yes.
Yes, this works really well.
Welcome, Dave.
Yeah, I think it's also time to greet Luke. He's backstage. He's doing all the technique for us tonight.
Yes, we totally forgot to mention Luke doing the technical side of things. And we also have a new organizer member, Roel, from whom you'll be hearing in the next couple of events.
Yeah, and of course Henk and Sjouk as well, but they are busy tonight. So
yes, we'll see you next time again. So
yes, but this works really well. So yeah, hi Dave, how are you?
Hi. Yeah, fine, thanks. That was a really nice session before me. I had to put my kid to bed, so I only started listening 10 to 8. But yeah, I'm ready for it.
Excellent. So you want to introduce yourself right now, or do you have a slide about it?
I have a slide that can probably help a bit. There it is. Yeah, so my name is Dave Ruijter. I'm a consultant in the data analytics world. I work for Mako, one of the Microsoft partners in the Netherlands. And you can find me on Twitter, LinkedIn. I have a blog. It's moderndata.ai. And I regularly blog there about the data platform and also a lot about Power BI. Today we will not talk about Power BI, or at least not much. It's fully focused on the Azure Data Platform side. And
yes, but you are well known for your Power BI cheat sheet, right?
Yeah. I created a 2-pager PDF with some great tips for primarily like starters for Power BI, but I know there's a lot on there that also the people that work have been working for it for a while with it. They also learn a lot from it. Some tips and tricks. I'm also a Microsoft MVP because of I don't know. I'm still surprised. Yeah, it's probably because of the community work that I do, and I really like doing that.
Yeah, something to do with it. All right, so we will make sure that we post a link to your Power BI cheat sheet afterwards for people to find it. And if you're ready for your session, I guess we can kick it off.
Let's do it. Oh, right. It's right now starting to rain here, and I'm in the attic. So I hope the noise from the window right here isn't too loud. Apologies for that, but I guess when I'm talking, I will overshadow the noise of the rain. But I had some experiences where it was so loud that it wasn't workable. But we'll see. Yes. So we're kicking off the battle of modern architectures. It's really great that Heini did the session before me, and we are talking about primarily the same subject, but I'm sort of ditching the Synapse preview stuff because, like Heini said, it's not in GA yet. It's not generally available. And for us to plan our enterprise-ready modern data architecture, it is really interesting, and I work with it. A couple of customers are already using it in production on small scale for small use cases, but for the big enterprise platform, it's not possible to select it yet. So you learned all about it in her session. So for me, that's easy to say. You know what it is. She talked about it, and you know why it's also hard to select it. But we'll touch on that in a bit. I don't know how this exactly works with the questions. Do you see them immediately when they come in? And if yes, then feel free to interrupt me when you think it's appropriate. I do have a couple of moments during my session where it's possible to to pause and to handle the questions, because I like that. I like it to be interactive, and that's a bit difficult in sort of a webinar style like this. But let's do it. Otherwise, there's a room at the end if we speed it up a little bit. But I can skip a few introduction slides because you are warmed up about it. So data warehousing in the cloud, from left to right, you have data ingest. You store it somewhere in a data lake primarily, and you have to process it, and then you serve it. It's sort of a three-phased approach. And simplified, my drawing is not like Heini. I really like that. She inspired me of using my pen, my service pen, more to draw those slides myself. So I've got some boxes right here, and for me, the orchestration is on the top. Azure Data Factory, primary choice of orchestrating your workloads in Microsoft Azure. That's no doubt about that. And on the far right, you have some yellow box right there. That's where you consume your data, the data from your data platform. It's yellow because, we all use Power BI for that, right? Then the ingest, store, transform, the load, and the result storage, which could be a different resource than the store from the second box. Let's talk about these in a moment, or take a moment to talk about these. We have two blue boxes. They're compute resources. We have to load data, transform data, and we have to select the proper engine to do that. One of the tools that the Microsoft Azure Cloud provides. I think the one at the store, let me grab my laser pointer. This one, the Azure Data Lake storage, that's also sort of not in the question, out of the question. The people use Data Lake, period. The result storage is a choice. A lot of implementations at customers, I use the Data Lake storage again to store my output that I've transformed and it's ready to use. So for this serving layer, I regularly use Azure Data Lake. But sometimes, depending on the type of workload, it's also necessary or preferred to have a SQL endpoint. And that depends on the consumers. If they want to use tools that they're familiar with, then they can use a SQL endpoint more easily than communicating with Azure Data Lake. The on-demand / serverless capability that the new Synapse Analytics provides makes it easy to have them like combined. So you end up with your serving layer and in a data lake. Every day, all the data is prepared, ready to use, and you also have a SQL endpoint. But that's an ideal world. We're not in there yet. For this session, primarily the tools of choice are in the blue boxes. But we have to remember that in one of the contenders, one of the fighters in the battle of modern data warehousing, the fighter is combining them. So you store the data and you have to compute in a single repository, single tool. So we need to select the best service. We've all been there, that maybe you already have the Azure portal in front of you, but you might be just wondering about it before. What kind of tool do you need What can you use? There's so many options. And yeah, that's the primary goal of this session, to just help you prepare for that choice and to give you my opinion and feedback on that. Why is it so complicated to select the proper resources? I think it will be easier if we have the new Azure Synapse workspace available. A lot of the choices are then, taken care of. We have one architecture, one tool to rule them all. But until then, it's going to be a combination probably. Let's find out. Why is it so complicated? Various sources, formats. There's schema drift and evolution that we need to take into account. Some tools do it better on this area than others. Your needs for scalability might vary, but yeah, usually I don't want to select a tool that's not capable of handling the big scale of data. So I need to take that into account. We have the monitoring auditing aspects, and also the tool needs to be agile. You need to quickly get results, in my opinion. And version control and ALM/DevOps, also important. Some tools, this is easy. Some tools, it's difficult. What does Microsoft suggest for this? They have this architecture currently on their documentation, and you see a lot of tools that might be familiar for you, but there are some ins and outs on this. Do you really need stream analytics? Do you need event hubs? Do you, Cosmos DB for serving your data? Synapse Analytics is in here, but remember, this is the GA version of their architecture. So they're talking about SQL pools right here, right here, formerly SQL DW. Do you need that? Maybe not. What they say is also it's only a subset, and your specific business requirements may ask for use of different services. So basically what they say is, it depends. Normal consultancy answer. I don't like this sentence, but it is so many times it's the correct answer. Over time, for me, I created an overview of the pros and cons of each service, each tool. So let's put them to the test. I've called it the Battle of Modern Architectures. In the warm-up fight, we see two contenders. So this is a battle, this is a fight, and usually you have a warm-up fight. Azure Synapse Analytics serverless pools or on-demand pools, that's the same thing. It's young and talented. I really like it, but we cannot use it in production. So not ready for the primary fight. And then there's also Snowflake. Personally, I don't have any experience with it. And last Saturday, there was a session from Koen Verbeek on the SQL Saturday Denmark about the introduction session for Snowflake on Azure. So you might want to check that out. Maybe there's a recording somewhere of a session, maybe another session like that. Keep an eye on it. It might be a choice for you, but not for our primary fight. So who are the fighters in our session? Azure Synapse Analytics, but then the formerly known SQL DW, the dedicated SQL pools. And we will use that in combination with Polybase to load the data in an efficient way. Another contender is HT Insights. Azure Data Lake Analytics is also around. Yeah, it is there, still there. And you might want to consider using integration services, good old tool in Azure. You can. I don't know if you are aware, but you can. And Azure Data Factory has also some great out-of-the-box options to compute your data. It's not only an orchestration service. So also a contender. And then almost last, the Azure Databricks. Yeah, What do I need to say here? Obviously, it's a contender. And then Power BI data flows as well. You think, what, Power BI, what? We'll get there. So first, let's talk about them one by one. I already said this is the formerly SQL DW. That's a really enterprise-grade, good old architecture choice. It's obviously a good contender for our choice, but it has some pros and cons. Heini already said it's a massive parallel processing architecture. So kind of like Azure Databricks, it has a cluster of machines, but it's really SQL Server oriented, and it can talk to the data in your data lake, but that's difficult. It's not as easy as compared to the other choices. But we'll keep it on the fight. So remember, this is the sort of the first selection of fighters, in the lead up to the primary fight. HD Insight. Well, I don't know about you, but for me, this is not something I've done actually. I've been around for a couple of years doing BI and data analytics projects. Who remembers the pig and hive and blah 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 blah? It's old. It's history. It's ancient, and it's also really expensive. And you have a really long lead time. You have to configure a lot to do this. It's not a managed solution like Databricks is, or Synapse Analytics. They're really PaaS offerings, and HD Insight goes a long way, but it's basically not. So for me, I'll like to burn it with fire. Just get rid of it. Then we have the third contender, Azure Data Lake Analytics. For me, I have warm feelings about this, but right now, the only thing I can do, burn it with fire. It was good. It had a job-oriented structure where you paid for the execution time of your jobs, but Microsoft killed it. There's no investment in it, and for a couple of years now, we're not using it anymore. So kill it with fire. Then the fourth option, SQL Server Integration Services. Well, do we really want to do this? My primary reaction is kill it with fire. But some colleagues say, whoa, no, Dave, stop making fun of it. There is a situation where you can benefit of this. Primarily for lifting and shifting your existing solutions that you have in an on-premises architecture using SSIS to the cloud. Then, okay, well, we'll keep it around. Azure Data Factory, the mapping data flows is, it has matured. I've done a couple of projects with it, or my employer, my colleagues, and they're really happy with it. And you can do a lot with the out-of-the-box activities that it provides. It's a UI-oriented flow, so if you're not a programmer, your SQL skills are also not really good, consider this, because it's really powerful and modern. Has a lot of benefits, so we'll keep it on the list. Azure Databricks, we don't. This is one of the top contenders, of course. How do you call that? In tennis, they have the ranking, like it suggests who might win the tournament. This would have the number 1 or number 2 on it. Spark-based, cluster-based, really good for also the unified analytics world. We will use it with the Delta, so that gives us some great options. Then Power BI data flows. It's on the list, but for your enterprise workloads on the IT side of things, so the data engineering side of things, it lacks a couple of features that we need. Good enterprise scheduling. We can maybe use Data Factory to do some of those schedulings, but it gets really complicated real fast. Versioning, really, really difficult. Designing them still is a bit slow. You get some validation warnings that take forever to complete. Microsoft is investing in it. They get better and better and better. I think in a couple of, like a long period, I don't know, I wanted to say a couple of years, but maybe sooner, this might be a good choice for certain companies to use as their enterprise data warehousing tool. It can ingest data, store data. It has a really powerful engine, Power Query. So yeah, in time, this will be one of the contenders, but not right now. So this leaves us 4. Let's go over them one by one. Volume is a bit soft. I don't know if you heard that, but what to call it. The first one is capabilities, then the developer experience, operator experience, security, and then a couple of roadmap items. You want to know if Microsoft is going to kill that contender in the future or not. And then round 6, coolness. So first round, capabilities. So let me first pause just a second, looking at the time as well. I think so far we're doing good. Are there any urgent questions that might require an answer right now? I don't know if I can hear you. Yeah.
We have one question. I don't know if it's urgent. What do we have? A good question in the comments. What is the difference between Azure SSIS integration runtime and Stream Analytics? Which product should I use for which use case?
Oh, Stream Analytics. Does it really say Stream Analytics? That's a really different.
That's more and more, I think, the real-time processing, right? The analytics where SSIS is more of a ETL kind of thing in my world.
Yeah, that's correct. So SSIS stands for SQL Server Integration Services, and that's a tool that's been here for 10 years, maybe longer, 15 years maybe, and it's a traditional tool that's perfect for batch data processing. The Stream Analytics offering is a cloud-based, event-oriented tool that you can use to process the incoming stream of events and do analytics on top of it in a real-time manner. So you can probably say, okay, please do something or give, you can aggregate the data and say, if the temperature of this sensor is above 90 degrees, do something, so alerting. You can also direct the data from the Stream Analytics after you've done your aggregating and your analytics. So you can also maybe score it based on a machine learning model that you have. You can send it to a couple of destinations out of the box. So, but it's really powerful, but it's completely stream oriented.
Yes.
And SSIS is a batch oriented offering.
Yeah, if you would use SSIS for your sensoring, then you would always be too late, right? So then the plant had already exploded.
Yeah, if you get it to work. If you, so that's also one of the downsides of SSIS, but we'll come to that in after a couple of slides. So let's go over the capabilities. So we first start with the Synapse dedicated pools. Again, it's a massive parallel processing system. Your data is distributed across nodes, and the results are then joined in the head or so-called control node, and they give you the result. The compute is separate from storage, and you pay for them separate. But it is one package. That's interesting to know. I am going to assume that you know a bit about this tool, because we need to compare them, and explaining all the tools is not what the session is about. It has really good inbuilt security. That's a pro. So you have a row level security, column level security, data masking, a lot of those mature offerings that you might need. And with other tools, you might want to use those, but you have to build them, add them, script those options out. Long slide from Microsoft Docs about this. I'll skip it, sorry. The pros, it can be sort of familiar to the SQL BI folks, but I say sort of because the MPP part can be difficult and complex. You have to learn what happens, how the distribution goes over your cluster of nodes, what you need to do to fine-tune it and optimize it, and how it works under the hood. And it doesn't work the same way as a normal SQL database under the hood. You can benefit from your T-SQL language and also your database application lifecycle management experience. Good other capabilities. The cons, you usually have to prepare your data a bit. I don't know how much, it depends on your workloads, to get the data in your Synapse SQL pool. And you can benefit of the Polybase offering. Basically, that gives you a declaration language where you can say, okay, my files or folder of files is on the data lake and in an Azure storage, and you point to it, and then you just say, copy the data. Just a couple of SQL commands is enough to copy the data from the storage. But in my experience, the performance is quite poor, and it has some overhead, and loading a lot of data works fine. But for maybe your intermediate level of sizes, the other tools are better and faster in transforming the data, loading the data, and so that's interesting and good to know. By nature, because it's a SQL server-oriented architecture, it has poor support for semi-structured or even unstructured data. You cannot really store photos or videos or whatever, the really unstructured data. The semi-structured, like XML, JSON, it can work, but it's not as good. Then second one, SSIS. This is how it looks in the UI. So it's a graphical user interface, works really well. Done a ton of projects with this, but it's really old school, like we discussed. It has a combination of simple and advanced options, both integrated into the offering. That's really nice. It's a really pro if you want to continue with existing solutions. You have really low initial investments. It's just lift and shift. People have done meta-driven generation of SSIS packages, good integration with Visual Studio. But the cons are, it's not really serverless. It just requires a Windows server to run. But Microsoft in Azure, they take care of that for you. But you have to turn on your server, then it runs, and then when it's finished, you have to turn off your server. That's not really uncommon in Azure, but it doesn't scale very well. XML and JSON support is really poor. And important is it has not really well integration with all the other PaaS services. Getting data from your data lake and storing it somewhere else using data, data that's for like streaming also, we talked about that. No really good integration. And I added a comment that this, if you go for this, we have no advanced analytics or data science capabilities. And the other options, they give you it out of the box. So that's a really important factor these days. Then, and I'm going a bit fast and cutting corners here and there, but we have a broad spectrum of evaluation topics, and we only have 1 hour. So I have to cut corners, but we can, if you have a question still, drop it in the questions, and then I'll try to answer that specific capability question that you have. Then the third contender is Azure Data Factory, and then specifically the mapping data flows option. Right here in front of you, you see the normal Azure Data Factory pipeline, and it has an activity to execute a so-called data flow. I'm not sure. Maybe it's called only data flows these days. So my mistake. It used to be mapping data flows, but you can execute it, and then if you go inside, if you take a look inside that activity, it looks like this. So that's a tree of activities that follows up each other. Nice flow, nice UI. It looks like SSIS, remember? So I like it. This graphical interface can be really useful for people that don't have programming experience or SQL Server coding experience, no Python. They can just learn the UI, click, and use some of the out-of-the-box samples and tweak them, and then they're good. And the way that it's integrated in the Data Factory gives you a lot of capabilities just out of the box. The code versioning is really well. The application lifecycle management, so deploying your code, can be tricky. It's not really the best, the best offering, but it's there, and you don't have to do a lot for it. Yeah, some examples of quick data discovery and checks that you get out of the box. Pros and cons. Its simplicity is a pro, and therefore it also has a low time to value. So just connecting a couple of sources, loading them into your enterprise data lake or whatever, it's quickly done. It has DevOps integration, but it's a bit clumsy. On the cons, it is still new, a bit immature, but I need to update this slide. It's not a con anymore. It's just neutral, and it still has not a lot of options for metadata-driven frameworks. So the looping.
Smartphone connected.
Oops. Can you still hear me? Let me know if not. Just interrupt me. My speaker just said something. Okay, perfect. It has a limited set of out-of-the-box transformations. So those UI options, you can run into a wall where something is not supported, and then there's not a really easy next level. You would have to use functions in Azure Functions, maybe some notebooks in Databricks to get your things done. So that's the downside. Streaming support is not there, and advanced analytics and data science also not there. Then, next option, Azure Databricks. I'm assuming you know the basic things about Databricks, but it's it is actually a sort of open source offering. They have an organization behind it, but it's largely open source, and it is a Spark-based cluster engine. Let me see if I have a better. No, let me go back one slide. I want to let you know it is from Databricks, but Microsoft has onboarded it, and now it's a first-party service. That's really important. There are other choices, maybe like Snowflake. They're not as on board as Azure Databricks, and the integration goes really, really far. It can really seamlessly talk to a lot of the Azure services. The integration with the Azure portal is good. It just uses the same account as your account in the Azure portal, and the billing, the billing. It's also integrated with your normal Azure billing, and it can also talk to Azure Power BI, to Power BI. Then important to know is the Databricks Delta integration with it, and that gives you ACID transactions, so you can read and write to the same file in Data Lake concurrently, and it gives you it ensures the integrity of the data. Really, really nice. So we're not going to do anything without Delta. Pros and cons. It's really versatile and scalable, and you can do a lot with it. It also supports streaming really easily, just adding one command in your code, and it's streaming supported. And it is a true unified analytics world. Your data scientist and data engineering can use the same resource, same portal, same data, and almost the same way of work. I think, it has an overlap, and they do more on this side. Data engineers do a bit more on the other side, but one unified experience. On the cons, it has a steep learning curve. It's not like you just spin it up and after like 30 minutes, maybe 5 minutes, you have your data transformed and already ready to use. And for mapping data flows, the data flow offering in Data Factory, it can be that fast. And for Azure Databricks, it takes more and more time. And it's also not serverless. You need to manage your clusters. Okay, so that's all about the capabilities. Are there any questions that we can best now answer? I've done it a bit fast. Maybe somebody says, well, how about this? Okay, then I'll just continue. Remember, we have 6 rounds, so some more moments to pause. Then the developer experience. For dedicated SQL pools, remember, the Synapse SQL pools. The tool to use would be Visual Studio. What? Visual Studio? Yes. My experience is that it sometimes crashes. Used to be worse, but now it still happens. And that's a pain in the ass. And I also need to update it. I need to think, what version do I need? Do I need to license it? Then infrastructure as a service, for the virtual machine, I think I mean with this for the developer, they need to work on a machine to have Visual Studio. And then there are good options to generate the code to help you develop your solution faster. And the IntelliSense is, of course, really nice. The collaboration option, so working together on the same tables and transformations at the same time, is so-so. You have to check in, check out, and agree on not overwriting each other's work. And schema drift support is not very well. Second one, SSIS, also Visual Studio. Testing your compute can be done in a sort of debugging mode with data viewers, where you catch your output before you actually write it. The source code is XML, so you can still do something with it, but my experience is don't touch it, but you can generate it with some tools. And again, schema drift is not very well supported. Then Azure Data Factory. The tool to use is just your browser. You can code it using the files. If you have it in Git, then you can do that, but nobody does because you have your UI. It's simple to start, but it can feel limited quite soon. If you're an expert and you just want to do it your way, then the collaboration is there, a bit easier, tiny bit easier than Visual Studio, but there's also a big risk of overwriting each other's work. So that's something you really need to take care of. Source code is JSON. A good testing via the debug mode. I like that. You can also see in a recent improvement, you can see the debug sessions and manipulate it a bit more. It's no longer a sort of black box. And then schema drift support is out of the box. It's just a checkbox, and then it works. So that's also nice. Databricks. We use the browser for that as well. And for the developer experience it's coding, no UI. There are some like output options and graphs that you can use, but building your transformations is coding. Collaboration, on the other hand, is wonderful. The experience is like if I have this notebook open, this script, and I have my cursor here, and you open this notebook, you see where my cursor is, and you see me typing, like when you're collaborating in Word or PowerPoint. It's amazing. Almost anything is possible, but yeah, again, the learning curve is quite steep. You can use multiple languages, also really important. And it has Visual Studio Code support. It says future, but it's already usable. And we can do schema drift. That's quite easy. So far, the developer experience. Let's do the operator experience as well. How do you, when the solution is ready, how do you deploy it or manage it in the lifecycle of moving it over your development and acceptance and production environments? How do you check if the daily loads are going well? How do you debug it? For dedicated SQL pools, you can use SQL Server Management Studio just to connect to the database and see the results. Azure Portal also has a couple of options to check it out. There is a resource governor that you should use, but it can be next level. There's a query store to remember all the queries that are executed, and to get your code over your environments, you can use proper CI/CD. It has schema compare options, and but one major thing, but it sort of is a thing for all the options, is cost management. But you can go like through the roof quite quickly with SQL pools. So you have to keep an eye on cost management. For SSIS in Azure, your orchestration tool would be Data Factory. So that's where, a lot of your, but that's for all. So let me, scratch that. So orchestration is sort of, you do it for all the options in the Data Factory. But if you want to check out code, fix it, see what's going on, then you use SQL Server Management Studio to browse the catalog of packages. And that catalog can be found in SQL Server. Deployment can be complicated, also versioning. So, comparing what's already on the server, your destination, to what you have newly created. There's a limited integration of monitoring. So it sends the results to Data Factory, but that's basically it. And debugging it, also, I think there are good ways of doing it, but it can be really complicated and intimidating. Then for mapping data flows, again, Azure Data Factory data flows, you would do it in a browser. You just go to the resource and you click on author and monitor, and then the Data Factory is in front of you, and the out-of-the-box orchestration options that you already use for your enterprise orchestration, it gives you a way to double-click to the actual data flow that's executed just in the same experience. So on like operator level experience, this is a really nice integration. There's no other tool that you have to dive into and to learn as an operator. It's all within Data Factory browser. For Databricks, deployments can be complicated. You have to manage the version of the cluster and the configuration of the cluster over your multiple environments, and also the notebooks, the versions of the notebooks, and it's a bit simple, the options that you have. Databricks is investing in that. There's a notion of projects coming. It's in public preview now, or private preview. That improves this a lot, but it's currently not very well. You use the browser, of course, and troubleshooting what was going on can be tricky. Seeing the intermediate results of a notebook depends on whether you have developed, how do you call that? If you have scripted your output to the command prompt, so if you have outputted your steps, your row counts, your status messages, then it's easier. But out of the box, it can be really limited. So that's that. So again, Databricks is wonderful, but those options are, important to consider. Are there any questions? I see we have a couple of them, like 10 minutes tops left. That's fine, but might want to continue if there's no.
Yes, we have one question. Well, there are multiple, but one that got asked in the last couple of minutes, and it is, which tool would you select for getting data from a web API and store it in the Cosmos DB? So it's a very specific question. Okay,
yeah, it's a bit off topic, so I'll answer it quickly, and then if there's time in the end, we can revisit. But connecting to a web API can be done using Azure Data Factory. It has a web activity that can get data from an API, and it has a couple of authentication support in options inside. If that's too limited, then logic apps would be a good option to use. And then both have the option to store the data in Cosmos. So that would be the simple answer.
Okay, perfect. Thank you.
All right. Then pricing. What do you need to think of and need to be aware of for our fighters in our fight? The dedicated SQL pools option depends on the DWU. That's the compute tier that you have your pool in. So it doesn't scale automatically. It doesn't really go out of control by its own, but to have a good performance, for your use case, you might need to improve it, and you have to think of the scaling yourself. Put it to a higher tier, lower tier, maybe turn it off when it's not necessary. So again, the SQL pools can be turned off to compute, so then it's not available. The endpoint is not usable. But the data will be still there, and when you turn on your pool, you can query it again. But when it's turned off, you don't pay for it. You pay for the storage, but the storage is kind of cheap in this offering. The expensive one is the compute. Remember that you can benefit from your existing SQL Server licensing a lot, so keep that in mind. An example for development workload. The tier is set to 500 DWU. That's like intermediate, and we have it on for 5 days a week. And then for a month, that's 200 hours, and in total it will be $1,600. Just an example. Remember, 200 hours a month for the developers to work with it. You have a couple of developers, something needs to be turned on for them to work with. On production, the amount of hours that needs to be turned on can be way lower. It's surprising, but can be surprising for you. But the actual cost of the production workloads are way less because you can turn it off when it's not necessary. And this is stating in an example that we have a 2-hour daily load. After that, it doesn't do anything anymore. And in this example, it's turned off. It has turned off. So this can be for scenarios where you load the data in a tabular engine, maybe in analysis services or Power BI Premium or any other destination. And then after that is finished, you turn off your pool. So then it's not reachable anymore. So self-service is out of the question for reaching the SQL pool. So that might not fit your scenario. The Azure calculator gives you options to put in your own numbers. SSIS. The runtime costs are depending on a lot of factors. Not really special for this offering for SSIS, but it is more difficult than compared to the others. The existing SQL Server licensing can really help here as well. And remember that it's based on a VM that has SQL Server integration services on it, and you pay for how long it's on and the performance of the server. Let's say we have a 3-day or a week development workload, because there aren't that many people with SSIS skills, so they don't work full time. Just joking. I just chose a server tier, and it's 230 euros for a month. So that's not really expensive. So it is not a fair comparison with the other one, because I chose 3 days a week and like almost half of the hours. But even if you multiply these hours by 2, it's also not in the same range as the development cost of a SQL pool. So it's not really expensive, the SSIS one. In production, I would say we have more machines, but less hours required. And then again, it's also 200 something. I heard some stories that this was way more. So maybe I'm just underestimating the instance that you need, or other factors, maybe the amount of virtual machines that you need, but scaling out is not really well supported in SSIS, so it doesn't really benefit to have multiple machines. So the cost is not very expensive. Data Factory, you can choose for a couple of tiers. One is compute optimized, one is general purpose, one is memory optimized. In the background, they use Azure Virtual Machines, and they have these choices. An example, combination of these two numbers, 250 and 50, so $300 a month for development workload. I'll share the deck so you can check out the numbers, but it's based on everyday usage all day long by the developers. So it's not really expensive, $300. Then the production workload, an hourly schedule to do a certain task. I took this example from the docs, so it's again comparing apples with pears. It's not apples and apples compared to the previous stuff. But so remember, this is a exercise on its own, but this exercise is a hourly run that takes 10 minutes to complete. But because of the nature of the data flows offering, the background compute turns off after 10 minutes of not being used. So that's the time to live. So you pay for 20 minutes. Then if you put that in the equation, you end up with $50 a month. That's not a lot. But it totally depends on your workflow, of course. But 20 minutes every hour is still combined over the whole day. A serious workload. And I think if you extend this compared to the others, it is still considered a cheap offering. So that's nice. Then Azure Databricks, a couple of choices to be made. Data analytics versus data engineering versus data engineering light. The docs can help you to select the best one, but normally I say use the data analytics one for your interactive clusters to collaborate together, and use data engineering light. Remember, if you do that, that's why it's here. Delta is not available, so we sort of not use this, never. This is what I'm talking about. For production, you can use data engineering in a lot of cases. For development, data analytics. If you compare the prices, 5 days a week of development machine, like not the machine, it's 2 machines, 200 hours a week, a month, 170 euros. Sort of comparable with all the other options. Production workload, again, 2 hours a day. A month, 60 hours, 160 euros. People say Databricks is expensive. It's not if you just stick to these approaches. But you have to pay attention to your clusters. Turn them off immediately when you don't need them. Don't scale them higher than you need them. And use the data engineering workload for production. Then it's really not that expensive. So we'll touch upon the roadmap for a tiny bit because we're out of time. I just want to say SSIS, there's no roadmap. Keep that in mind. It is mature, but there's no development. Data Factory mapping data flows or data flows, still under development. Databricks is really highly development and invested in. A couple of new things. I have some slides, but we'll skip it. What's coming? Still some things to come. Spot VMs, so you can benefit those to make it even more cheaper. And last but not least, the coolness. Heini also mentioned this, the previous speaker. You need to consider your people who are working with these tools. And people are looking for the shiny things, the Databricks offerings. Maybe Data Factory as well. They want to work with a data lake. They want to have good DevOps things. And they want to work with a tool that's still under development. They want to see what's new every month. And if you check out job offers, these are in Dutch, but people are searching for Data Factory, Azure, Databricks. Sometimes they mention also some SQL Server stuff, but it's always accompanied by the more modern new tools. So keep that in mind. This is the list of the things we talked about. Sorry that we had to do it in this tempo, but it was only 1 hour. If you have questions, I'll hang out a bit more, and you can reach me on Twitter, Dave Ruijter, also LinkedIn, and on my blog. Thanks for attending the session. I enjoyed it, but there's so much to talk about. I feel like I need more time for Q&A. Maybe that's the most important after dumping all this information, but I cannot talk about it faster. We just need to skip a couple of contenders in the fight. That might help. Yes.
It still was. I love the comparison. So thank you very much. It was very helpful to see the comparisons on functionality, and especially also the costs to help us choose the tool we need for the right use case. And I think we still have a couple of questions, right, Jorrit?
Yeah, we do actually. So one of the questions I personally have is, okay, so if you have a scale from easy to hard in each category, right, from ingress to ingest to report, I didn't see the outcome of the battle, really, but which one would you pick for somebody who's really novice, want to start with this? Which one would be the easiest in each category if you just need to name one of those services?
So with the categories, are you referring to these rounds or to the ingest, compute?
Yeah, exactly, the latter, yeah.
Okay. So it doesn't really make a difference splitting it up over the dimension. Just over the whole spectrum, Data Factory data flows is on a scale of usability 1 to 5, 1 being easy. It's the 1 and 2 option. But as I stated, it gets you going really fast and you get results fast, but you can run into a wall. If you want to do the real more complicated things, or you have 500 tables that you want to load, and they have individual changes for each table, you might end up doing a lot of manual work because the metadata driven part, it's not up to the same level as the other options. And so that answers your question. I think on the other scale, you have SQL pools and Databricks, sort of the same complexity, but other attention points. They're both oriented for the more experienced coding-oriented developers with their own pros and cons. But yeah, I didn't show a winner. But if you would put me on the spot, I would say for now, you have 2 good options, and that's the Data Factory approach with the mapping data flows and Databricks. I don't see, to be honest, but I might I might run into a fight myself with somebody who is really enthusiastic about SQL Data Warehouse or SQL Data Pools, because I'm not a fan of it, and I think the benefits that the Databricks offering gives you for unified analytics and a more modern approach, better support for unstructured data, semi-structured data, a better connection with your data lake. That's for me the primary choice, and so those are the sort of 2 winners. For the easy camp, that's the Data Factory. For the more experienced camp, you have Databricks.
All right. Well, that was exactly.
This is going to change a bit, like a lot, if Microsoft releases the new Synapse offering.
Okay. All right. Well, thank you.
Also mentioned during the operating experience for the SSIS in Azure, the deployments are a real hassle, but does that mean that for this specific use case, you can't use the Azure DevOps way of deploying SSIS?
Yeah, you can, but I think it will be a combination of regular DevOps stuff and good old integration services deployment scripts. And I know that there can be some really annoying compatibility things, and there's no out-of-the-box task by Microsoft. Maybe there is currently, but to pick up a project and deploy it. But there are, I think, in the marketplace, a couple of things you can use. But I don't know if you want to depend on marketplace code for your enterprise deployments. If they break, you're kind of stuck. So it is doable, but it takes a combination of tools and.
And if you run into problems, it's still still the same work you have to do to get it up and running again, because it's also always a one-way street, or you push stuff through, and if that stops, then it's just clearing up the mess and starting again for the new deployment.
Yeah, that's right. So it takes me back to the ISPAC deployment days. The schema compare is way easier. The data factory deployment is normally easier, but they also can be sort of a clumsy setup.
Okay, thank you. I think we have the same question for you as for Heini. We're having Rohan Kumar, Corporate Vice President, Azure Data at Microsoft next month. What amazing, intelligent question do we have to ask him?
Well, that's an amazing speaker that I want to make sure that I'm present.
You can, of course, you can think about it. We're now putting you on the spot, and just ramping up the pressure here. So it's totally okay if you get back to us, and then we'll relay it on the event page.
Yeah, that's a good option. I think that the most common question on this that people want to ask him, and I'm also curious about his answer. I've seen a couple of people answer this question from Microsoft as well, and he will know that this is coming. But what is it with Databricks versus Synapse? Microsoft says they love Databricks, and I know that they do. They also show that, but it is sort of two captains on the same ship, and with really similar options to choose between. And I've played with it and used it at customers. I know what you can do left and what you can do right, and it's not exactly the same, but they have a big overlap. And what is their strategy behind that? Are they competing with Databricks? And they say no, but I'm really curious about how he phrases this answer and what the latest answer is to this question. And I'm that would be my primary question.
Well, thank you. Then we'll be putting him on the spot for that question, probably. So that will be nice to do. Yeah, thank you so much.
Yeah.
It was a very good session. And
you're welcome.
Here.